All right, hi everybody. I'm Tony Arcieri. Tonight I'm going to talk about Tendermint Kms and Abscissa, our Rust application framework. This is kind of a crazy day to me with Congress asking about like the software supply chain of nightly Rust and blockchains, and here I am talking about Rust and blockchain. So yeah, I'm Tony Arcieri. I've been doing Rust for about 5 years. I've been doing blockchain stuff full-time for about 3 years. I'm co-founder of Iqlusion. We are a proof-of-stake validator company. So we host infrastructure for proof-of-stake blockchains, also developing a lot of stuff with Rust in-house. We primarily focus on Tendermint, but we're going to validate a lot of networks, including we're very interested in Solana, for example. So today's talk, I'm going to talk very briefly about 4 different things. First one is the Tendermint key management system. So this is a key storage solution we built specific to Tendermint. So it's kind of blockchain network aware. But in the course of building it, we built a few generally useful libraries. Some of them Brian already mentioned. So one is Signatory. Signatory is a general purpose multi-provider digital signature library for Rust. So it's kind of an abstraction for doing digital signatures. We also made ubhsm.rs. So we implemented effectively the SDK for these inexpensive ubhsms from Ubico from scratch in Rust, and I think made possibly the only, or at least the most mature HSM client that's available in Rust today. And finally, I'm going to talk about Abscissa, which is our security-oriented Rust application framework. So let's talk about Tendermint Kms. So it's a key management system. It's on GitHub. There's the URL at the bottom. But to start with, let me just talk about what Tendermint is. So at its core, Tendermint is a BFT protocol. So who here has heard of Raft? Consensus algorithm. So Raft, the core idea of Raft was taking this older protocol, Paxos, and combining some of the operations within it to simplify them to use a single operation to do many things. So Tendermint is the same idea, but instead of starting with Paxos, it started with PBFT, practical Byzantine fault tolerance, and it applies a similar simplification. So it is also, in Tendermint also describes an implementation of this algorithm in Go. So it's designed specifically for proof-of-stake blockchains. So the idea is you have several of these validators / block producers. One of them is picked via a round-robin protocol to produce a block. The validators all validate that block through this sort of like pre-commit multi-round protocol. And then they sign each of these blocks if they think they're valid with a 25519. So you do this 2-stage protocol, pre-vote, pre-commit, and at each stage they sign the blocks they think are valid and should be the next block. So Tendermint also has this thing called the application blockchain interface. So where most blockchains are tied to a specific virtual machine like the EVM or the 2 we heard about tonight, Tendermint is kind of agnostic to that. So you can just plug in whichever consensus engine you want. That's called your application. There's still this notion of transactions, but transactions to Tendermint are opaque and application specific. So you can plug in WASM or what have you. The idea being that Tendermint, it can unite all of these different blockchain networks together through this protocol called IBC, the Inter-Blockchain Communication Protocol. And probably one of the most notable things about it is some of the only production proof-of-stake networks are based on Tendermint. So the core one is Cosmos Hub, but then there's also the Iris network and Terra. Iris is basically the Chinese equivalent of Cosmos Hub, and Terra is a Chinese stablecoin. So these are all production networks running on Tendermint. So what is Tendermint KMS? So the core idea was we wanted a secure key storage solution for validators, and we didn't want just one supported HSM, so it supports both EBHSM2s and ledgers, along with software-backed keys are also an option, although I certainly prefer HSMs for this purpose. So another thing we wanted, because Tendermint lets you run several of these networks, they each have their own consensus, the idea was to have a central signing service, so every time you spin up one of these new networks, you don't have to deploy new hardware and new HSMs, and you can kind of share these HSMs among multiple of these networks. Some of its key functions is double signing. So BFT algorithms depend critically on the ability to make sure that the validators are not signing two different blocks. This attack has a few different names. There's duplicity or equivocation. Tendermint specifically punishes validators who double sign. In fact, there was a big double signing event on Terra recently. So if you double sign, your MAG goes poof. You get slashed is the term. So one of the Terra validators got slashed about the equivalent of $1 million for double signing recently. So it's critically important that you don't double sign. And finally, Tendermint KMS is running in production on several validators. So this is a production Rust application, and yeah, it's pretty much all pure Rust. Some of the only C code in it is libusb to talk to the EBHSMs. You can find it on GitHub under Tendermint/KMS, and all the other projects I'm going to talk about can all also be found on GitHub. So let's talk about Signatory. So Signatory is the signing abstraction library I was talking about earlier. So it presently supports ECDSA and ED 25519. So we've support ECDSA over two different elliptic curves. There's the more traditional NSA created NSP 256 elliptic curve, and also SecP 256K1, which is kind of ubiquitous throughout cryptocurrency applications. ED 25519 is this cool new kind of up and coming elliptic curve that's being widely adopted for lots of different applications. So Signatory supports both. It has a type-safe implementation of especially ECDSA. It's generic over curves. It's really it's using generic array and type num right now, but it's really been designed with the goal of supporting features like const generics to have type-safe bindings to ECDSA. There are providers for several popular Rust libraries. So ED 25519 Dalek that Brian talked about earlier is one of my favorite Rust libraries in general. I think the world's fastest implementation of ED 25519. Ring is another very mature and popular library for doing Rust cryptography. So I was talking about using that NSP 256 curve for ECDSA. It supports that. It doesn't support SecP, so maybe less interesting for cryptocurrency applications. Some of the other providers is Blockstream created libsecp 256K1, which is probably the most mature library for that purpose. So there is a ECDSA provider for that. And finally, it supports sodium oxide as a alternative ED 25519 library. But what is one of the most notable thing about it is it uses a common set of traits regardless of whether you're using one of these software implementations or whether you're using an HSM. So I think this has classically been a mistake in a lot of these sort of like multi-provider abstractions in other languages. They make two different APIs, one for software and one for hardware. There's like PKCS11 is the big traditional one. So the problem is everybody writes to the software APIs, and then you can't just easily plug in an HSM to any library that uses this. So Signatory has been explicitly designed so there's one API regardless of whether you're using a software or hardware backend. It just kind of abstracts over that. So right now there's two HSMs supported, UBHSMs. I'll talk about that next. And then ledgers, but unfortunately our ledger support is only for Tendermint right now. We do plan on adding more HSM backends. Like we would love to support keychain services on Macs, so you can do Touch ID and that kind of thing. So next, let me talk about UBHSM RS. So UBHSMs, you can kind of see it there in Ferris's hand. It's like this little tiny YubiKey size token. It does all sorts of cryptography. They cost about $650. So that's much cheaper than a FIPS HSM, which will run you north of $10,000 or more. So this is also under Tendermint on GitHub, UBHSM-RS. So really quickly going over its features. So it's pure Rust. So I started originally in CoreOS, had tried to write C bindings to Yubico's SDK, which at the time was closed source, and there's just so much. I contributed a few things to that implementation, but there's so much unsafe code there. I'm like, this is crazy. So then it turned out it's actually just basically using industry standard protocols. So I ended up re-implementing all of these in Rust, writing it on top of the libUSB crate, and we get a crate completely free of unsafe code that can talk the protocol natively. So most of the functionality in the UBHSM is available through this library. So I mentioned ECDSA and HEAD 25519 as signature algorithms, but it does a whole lot more. So you can export and import encrypted backups of keys. Can also encrypt arbitrary data. It also supports HMAC. It also has some pretty cool audit log functionality where it keeps an almost blockchain-esque like hash-based log of every single thing it does. So you can keep an eye on what people are doing with your UBHSMs. And then finally, as part of developing Tendermint KMS, testing is really hard with HSMs, especially if you want to do things like CI, where you're using like a hardware device, and CI is pretty impractical. So it contains a partial software re-implementation that behaves mostly like the UBHSM that you can use for testing and CI and all that sort of stuff. All right, moving on, let me talk about Abscissa. So in the course of developing the many Rust applications we have at Iqlusion, we end up creating this sort of like copy-paste boilerplate we would use to spin up an application. And after doing this so many times, we did the hard work of kind of ripping that all out and making it into a library with an application generator. So quickly, so what is an Abscissa? Abscissa describes the elevation over the x-axis. So kind of the pun here is like, Abscissa gets your application off the ground. It's kind of a double pun here. So it's also named after this thing. This is a statue called Cryptoss, found at CIA headquarters. It's still unsolved. Well, there are 4 panels, 3 of them are solved, the 4th one is not. Abscissa is the key to the K2 panel, the second panel. So it used a thing called a visionaire cipher, which you should not use visionaire ciphers unless you're making cryptography puzzles. But that's what it decrypted to. And in case you're curious what Iqlusion is, Iqlusion was part of the solution to the Cryptoss K1 panel. So it's kind of a reference to this statue. So what does Abscissa actually provide you? Well, it's a bunch of things. We developed it both for command line applications and for network services. So it's pretty general purpose. So we've written several utilities. We have like a file archiver utility called Arcieri that does encrypted zip-esque sort of things. I'll talk a few more about a few more of the things it's used in. So one of our biggest goals has been eliminating as many dependencies as we can. So it comes with about 30 runtime create dependencies right now, which sounds like a lot, but when you look at things like request, the HTTP library using like 150, we've really tried to get that down as much as possible while providing a lot of functionality. And we think Abscissa, since we're taking this sort of like heavily security-oriented focus, we think it's particularly interesting for people writing blockchain applications in Rust. So really quickly, here's what's using it. Tendermint Kms, I already mentioned. I also work on the secure code working group for Rust. And one of those projects is RustSec. We have this utility called Cargo Audit, which will audit your Rust application for crate dependencies that have vulnerabilities that have been logged to our vulnerability database. So that's using Abscissa as of a few days ago. There's also, Parity that was mentioned earlier developed a open source Rust implementation of a Zcash node. So this is Zebra. So they did that in collaboration with the Zcash Foundation. So Zebra is now using Abscissa, and we have several internal tools we are in the process of open sourcing and will eventually do announcements about. I mentioned one of those is Arcieri, or file archiver. We also have a deployment utility called Canister, kind of oriented towards Amazon Firecracker, which is a very new, interesting VM from Amazon. So what functionality does Abscissa give you? So command line option parsing. So you may have used clap for this. We use this other crate called Gumdrop, simply because clap has a lot of overlap with the stuff Abscissa does. And it has a lot of dependencies too. So it's kind of like a lot of duplication of functionality. So Gumdrop has no dependencies and is great to use as a library. And it was written from the ground up to kind of be a proc macro DSL for argument parsing. So another thing it has is components. Did anybody see the RustConf 2018 closing keynote on entity component systems? So Abscissa is not an ECS, but we've taken some of the ideas from that talk and used them to build kind of reusable functionality you can share across applications. So there are two components built into Abscissa itself. One handles terminal interactions, so kind of colored terminal output, and the other handles logging. So far, there aren't any other open source components. We have a few internal ones that do things like key management and that kind of thing, which we eventually want to open source. I guess the other thing components do is figure out ordering. So all our logging goes through the terminal. So there is this cool sort of partial ord-based thing that looks at all the components, kind of like a dependency injection framework, figures out the order they need to start up in, and then starts them up in the correct order so they can go talk to the other components and use the ones they depend on when the application boots. So configuration files. So It has a nice simple way to figure out where your configuration file is, parses it using syste, and then it also provides the ability to override things in the configuration using command line arguments, and it supports hot reloads of the config, if that's something you're interested in doing. So it's error handling. So it contains a generic error type based on the failure crate. So this handles things like causes, backtraces, and eventually we will want to hook it into things like exception reporters and that kind of thing. So as I mentioned, as logging, so it uses the log crate as a facade, but it has its own log driver implemented as a component that logs through the terminal crate, is kind of intended for things like systemd, journald, or Docker logs, or however you want to collect logs through standard output. So it's got secrets management. So one of our other in-house crates is called secrecy, and it talks to another one of our crates called Zero Eyes. Really the main thing it does is try to prevent secrets from being exposed. So this is really good if you have secrets in things you're deserializing with syste. So it prevents them from getting logged by debug, and then it tries to wipe them out of memory when you're done. And then finally, as I also mentioned, there is this component for doing terminal interactions and color terminal output. So one of the things I developed it for was cargo audit, which kind of mimics cargo. So if you want to make a cargo plugin or something that outputs colored output that looks exactly like cargo, it's all built in and ready to go. So if you want to try it out, the main thing you want to do is cargo install Abscissa, and then this will install a little command line utility that contains a application boilerplate generator. So you do Abscissa new and give it an app name, and much like cargo new, it will spit out this entire app skeleton that's ready to go. So it includes all of these little pieces, and it includes acceptance tests. It has its own built-in acceptance testing framework you can use to test your command line application. So I'm not going to do a deep dive into how it all works in this talk. You're not going to see any code. I'm basically done at this point. But if you're interested in that, we will have a blog post up tomorrow that does a big deep dive into this. Kind of what the different parts of an Abscissa application are, how they work, and what the generated boilerplate looks like. So that's all I've got. Here's some links, and if I have time, I can take questions. If not, come find me, and I'll try to answer them.
Okay, and that's all for today. Thanks for everyone to coming, and we have Brian hiding there, and Shaw here, and Maxim there, and Tony here. So feel free to talk to them later on. We still have a lot of drinks at the door. Then enjoy your time, hang out with all the speakers here. And thanks, everyone. And don't forget to check wrestlingblockchain.org and check the updates. Oh, and we still have ongoing events planning in San Francisco and Berlin and in China. Just everyone have